So 1.8 is words into symbols. First of all, we'll go through the objectives, but where do you usually see words into symbols? What kinds of problems? What do we call them in math? Word problems, okay? Word problems, which so many students fear, but they're really not that bad. And you're going to see this year that we're going to do a lot of them. You'll get much better. If you're really good at them already, you're going to like this year for sure. If you struggle with them, you're going to like it also because you're going to improve. Okay? But we will do a lot of word problems because in real life, when do you walk around in real life saying 2x plus 5 equals 12? Let me solve that. Nobody does that. Those equations come from some scenario, right? So when you get on the subway, here in New York it doesn't matter, but you get on the subway in DC, the way the subway works is a function of the distance traveled. So if you go from like location A to B, it might cost $2. But if you go further, then it's $3. Those are functions. You can write variables to represent them. You could talk about X being the mileage or the price per mile or the amount of miles. And that's what we're going to do today. Okay, so the word problems, they are difficult, but they're really, really important. Because in math and science, that's where you're going to see things. You're not going to see just equations. Okay? So we're going to take words and turn them into into a logical or mathematical statement. And then we're going to turn word sentences into equations. Georgia? Yes, you told me. Make sure you just take a look. Okay? All right, so example 1. Represent each word phrase by an algebraic expression. Use H for a variable. So for part A, a number is decreased by 4. What would that look like? What would that look like?
H minus 4.
H minus 4. Because it means you start with a number, H, and you decrease it or take away 4. You take away 4. So this first one is going to be H minus 4. So all we're doing right now is we're calling a number H, and we're thinking about what's happening to it. What's the common mistake that some people might have on this one? Chris?
4 minus H.
Yeah, 4 minus H, okay? If it's decreased by 4, it means you're taking away 4, thus the 4 needs to be negative, not the H. Okay? Part B. Part B, Worth.
8 plus 5H.
So 8 more than 5 times a number. So 5 times some number is 5H, and then it's 8 more than, so it's going to be plus 8. Could you put the 8 at the end? Absolutely. 5H plus 8 also works. Okay, why does that work? Who remembers? What law is that of addition? Commutative. Commutative. I actually was doing a lesson in physics the other day, and one of the things we were able to do was look at our dimensions and our units because of the commutative law of multiplication. So it's not something that just, goes away. You're going to continue to think about it, although you don't always say it, right? In the back of your mind, you should know that you could flip these two around because of the commutative law, but you're not going to always make that statement. Part C. Part C. Who's got part C for us? Hannah.
I'm not sure, but it's an H minus the square root of H.
Close. Very close. Help her out, David.
Oh.
Okay, so you realized it, right? Good. H minus H squared. So the difference. What does the word difference mean, everybody? Subtraction. The difference between a number, that's the H in the front, and its square. If I said to you, what's the difference between 7 and 2? What's the difference between 7 and 2?
5.
5. What if I said, what's the difference between 2 and 7?
Negative 5.
Yeah, technically it's negative 5. And that's why this becomes a little tricky. Okay? When you hear the difference between, and you hear two things, the first one is always the first part. Because the order does matter with subtraction, right? 5 minus 3 and 3 minus 5 are two completely different things. Subtraction is not commutative. Subtraction is not commutative. All right. Part D. Part D. Who wants to do that one for us? Summer.
2H plus half the absolute value of H.
Plus half the absolute value of H. Good. So the sum, so it's a plus, of twice a number is 2H, and half, that's the 1/2, half that number's absolute value of H. Questions on D? Any questions on D? Okay. Let's move on to E then. Let's move on to E. Twice the sum of a number and 9. Twice the sum of a number and 9. Ida.
2 times the quantity of H plus 9.
Very good and well said, the quantity. So twice, and I emphasized that when I said it, I hope you noticed, twice the sum of a number and 9. Well, here's the sum of a number and 9. We want double that. So we have to think about the 2 being on the outside. So far, so good, right? Let's go on to word problems now and take a look at some examples. All right. James left his house and drove for T hours. So T could be what? Anything, good, or a number, some number, any amount of time. So he drove for T hours at 50 miles per hour toward the city. If his house and the city are 200 miles apart, then how many more miles must he drive? All right, let's start with a hypothetical. Let's say, again, 200 miles apart. If I drive 20 miles, how many more do I have to drive? 180. If I drive 100 miles, how many do I have left? 100, and halfway there. If I drive 150 miles, how many are left? 50. You take the number 200 and you subtract the amount of miles you've driven. Agreed? You take the number 200 and subtract off however many you've covered already. So we know to start that it's going to look something like this. Would everybody agree with that statement? You need to think about it logically and understand what's happening here. Whatever distance you've traveled already, you're subtracting that from 200. That's what this is. But we need to figure out what goes in this blank now. We need to figure out what goes in this blank. Who remembers from their last math class? Distance, rate, time. What is our formula that relates those things? Distance, rates, and time. Francis. D equals RT. Okay, so let's jot that down at the bottom just as a side note. Okay, put a little side note down here. D equals RT. What does D stand for? Distance. What does R stand for? Rate. And T, everybody? Time. So, what is 200? Is 200 a distance, rate, or time?
Distance.
Distance. How do you know?
Because the house and city are 200 miles apart.
Good. Units, right? Your units. It says miles. So if I have 200 and I'm subtracting another distance, right? This is going to be a distance here. But a moment ago we said that distance is rate times time. Well, in this problem, what rate is he driving at? What rate, Chris? 50 miles an hour, right? And look how I write miles per hour, by the way. Please do that. I know you want to write MPH, but miles per hour, we want to think about the fact that it's miles over hours as units. In physics, you're going to see how important that is. Now, how much time goes by? How much time goes by? Worth, how much time?
T hours.
T hours. What does that mean? T hours.
Any number of
Yeah, some quantity of hours. Well, if 2 hours went by, that's too easy. If 3 hours went by, and James or John James was driving 50 miles an hour, and 3 hours went by, how many miles did he drive? 150, right? 3 hours go by, 50 miles an hour, 150 miles went by, or 150 miles were covered in distance. So what you end up doing here is you multiply these two, right? So who can tell me what goes in this blank, really? What would end up going in that blank right there? Ida. 50T. Okay, let's take a look at that. Okay, let's take a look at that. T has units of hours, so this would be really like 50 times T hours. That's what's really going on here. And what happens to the units of hours?
they cross cancel out.
Good, cross cancel. Very good, good word. Cross cancel. This is in the denominator of the units. This is in the numerator of the units. They cross cancel, leaving behind just miles, which is what we wanted. This is units of 200 miles. So this must be something in miles. Well, you're left with 50T. 50T. Okay? So when you do these problems, what's something you might want to think about? How would you do this? If you had a different problem, what might you want to think to help you out if you're struggling?
I have a question.
Hold on one second. What might you want to think in these problems if you're struggling? How might you help yourself? What's one way to think about these?
Substitute variables for values.
Yeah, pick numbers. SAT test. When you have struggles, think about numbers that make sense. Try and pick values and see what you would do. That's how we started this problem. I started by saying, if you go 40 miles, or whatever I said the number was, how many are left? And that gave us the notion of subtraction. Then we went on to say, all right, well, to find the distance, we need to know the rate times the time. So think about numbers. We picked 3 for time for the hours and said, well, that would be 150, so 150 would go here. Well, it's just a product. So try to make some analogy to something that's easier for you. Summer.
I was just wondering why we're multiplying 50 miles per hour times hour again.
Times t hours?
Yeah, like, why are we multiplying it if it's in the denominator still? Like, wouldn't hours in the denominator be the same hours over there?
Yeah, that's why they canceled.
Wait, so you don't actually have to do that? Like, multiply them?
You do have to multiply them. How would, if you were walking down the road at 10 miles an hour and you walked for 2 hours,
Yeah.
how far would you go? 10 miles an hour, you walk 10 miles every hour, but you walked for 2 hours. How far would you go?
20 miles.
20 miles. How'd you get that answer?
You multiply?
10 times 2, right?
Yeah.
So you multiplied your rate times the time you went for. The rate is 50. The time elapsed is t. It's unknown. So that's why you're multiplying those two. The units are just showing that when we cancel, we're left with miles, which is what we wanted, because 200, its units were also miles. Okay?
I was confused. It's like I thought the t canceled out too.
No, the t wasn't canceling. It was the units of hours that were canceling. We're left with 50 t, and the units are just miles. I don't have to write miles at the end here, because I'm writing an expression. But the units are just a balance and a check. Okay? Other questions on this one? Hannah?
200 is the distance, right?
200 is the overall distance, correct.
So why would we be doing 200 equals?
Because 200 is the distance, read what it says. How many more miles does he have to drive? This is the total amount of miles he needs to drive. This is what he has already covered. So when you subtract them, that's how many are left. It says how many are left. If you drive 50 miles out of the 200, you're left with 150, right? So that's where the subtraction is. It's not an equation. That's the thing here. Remember, this is not an equation. This just is asking for more of an expression. Okay, some word problems, you use equations. This just said, how many more miles must he drive? You could write, if you wanted to, you could write like equals miles left, meaning the miles you have left to drive. Okay? But that's what you're looking at here for this problem. Let's look at number 3. Can I get a reader for this one? Nice and loud for us, please. Nice and loud, Natalie.
Find the measure of the third angle of a triangle in simplest form if one angle has a measure k degrees and the measure of the second angle is 15 degrees less than half the measure of the first.
Okay. What might you do in a problem like this to help you? What might you do to start a problem like this? Yeah, draw a triangle, please. Whenever a problem has geometry involved, give yourself a sketch. It helps so much. So, in this problem here, we know nothing about whether it's equilateral or right triangle. We don't know anything about that, right? So just draw any triangle. It doesn't matter what it looks like. Just draw a triangle on the page somehow. Now, it says that the first angle is how many degrees? How many? K. So let's label it anywhere. Call the top one K. It makes no difference. Okay? It doesn't matter which one is which. It says that the measure of the second angle is 15 less than half the first. Well, here's the first. What is 15 less than half of this quantity? 15 less than half of this quantity worth.
K over 2, or I guess the quantity K over 2 minus 15.
Good. Okay? K over 2 minus 15. Or you could say 1/2 K minus 15. Same thing, right? Because multiplication and division are just inverse operations. So it's half of K and then take away 15. That's the first two angles. That's all we've got for this problem. What does it ask us to do? It says find the measure of the third angle. Well, that's kind of weird, right? Because I don't really know any numbers just yet. I don't really know any numbers.
Can I see if I can set up the equation?
Yeah, absolutely.
You do 180 minus K, minus K minus, wait, I'm sorry. 180 minus K,
Minus the quantity.
why?
Because you're gonna add these two together, right?
Yeah.
And then subtract it from 180. So we'll put a plus sign here,
Okay, yes.
and we'll show it that
I
way.
just was confused about the parentheses. Okay, yeah. So K over 2 minus 15 plus K.
Good, well done. So let's take a look at this now. How many degrees are in a whole triangle, everybody? 180. So if you have two of the angles, you could subtract that from 180 and get the third angle. Well, that's what we're doing here. 180 minus the sum of the other two angles. Here's the first angle, k over 2 minus 15, plus the other angle, which is k. Okay? Okay. Let's take a look at simplifying real quick. What would this simplify to? 180, now the negative on the outside, what do I have to do to it? Distribute it to every term. So we really have this. Okay, so again, take the distributive part here and send it to all three of these. Okay? So yeah, we're going to end up getting a positive 15 there, which gives us 195. Right? 180 and 15. We did.
So would you multiply 180 and 15?
Absolutely not. 180 is another term. This is really a 1 here. Okay?
I was confused that there were 3.
So distribute the negative 1 to each of those first. The negative k over 2 and the negative k, what does that become? That's the hard part for some students. You got negative k over 2 and you've got a negative k. You can combine them because they're like terms. What does it become? Liam? Not k squared. You're not multiplying. There's no multiplication involved. Other Liam. Sorry, Liam Tobin.
Negative 2k over 2.
Negative 2k over 2. Close but not right. Close but not right.
2k over 2.
2k over 2, not 2k over 2.
K minus k over 2.
K minus k over, not k minus k over 2. Here's how I want you to think about this, okay? Because this is what really troubles some people. If you have half of a number, how much percent is that? 50%. If you have a whole number, how much percent is that? So what's a 50% and 100%?
150.
150%. What is that as a decimal? What is that as a decimal? 1.5. 150% is 1.5. So this is really, when you put these two together, you're going to get 1.5, but with a negative sign. Okay, so negative 1.5k, or negative 3/2 k.
I'm saying like k over 2. Oh, that would be combining it.
No, you're going to be combining them, yeah. So you can go like this, or you can do this. Alright? If you want to make a common denominator. Those of you that were trying to put these together, I think you just forgot your common denominator here. Take a look. If you made this a common denominator, for this minus k right here, this would be just 2 over 2. And then you'd have negative 1, negative 2, giving you negative 3. Again, I'll show what I'm saying there, because I feel like people are still confused. If you got this, can somebody throw on the air conditioner over there? Say this is the scenario, and we want to have a common denominator. We need to multiply this by 2 over 2. So it would look like this, right? Okay? The denominators are the same. Summer, focus. The denominators are the same, so you carry the 2 over. Negative k minus 2k is negative 3k. And take a look. That's what this is right here. Okay? So you can do it this way by finding a common denominator, or you can use number sense and say, well, this is really 50%, this is 100%, that's 150%, which is really like 1.5. Okay? Either one of those are correct. It's up to you to choose which is easiest for you. If you're struggling with fractions, you need to either get some work and do some work on it, or at least come see me about it. Because stuff like adding and combining fractions, that's stuff that I'm not going to go over. I'm not going to stop to talk about how to put these two together. I'm doing it now because it's the beginning. But as we progress through the year, I'm just going to fly through those kind of parts. We're not going to stop and go through every step. Number 4, in terms of m, what is the sum of 5 consecutive even integers if m is the 4th integer? Here's a problem where it might be useful to make what's called a let statement. So we'll say let m equal the 4th integer. The 4th integer. Now, they're consecutive and they're even. What does that mean? What does consecutive mean, first of all? In order. Good. So you need examples of numbers that are consecutive. 1, 2, 3, 4, 5, etc. If they're consecutive and even, what would they be?
2, 4, 6, 8.
Yeah, 2, 4, 6, 8, 10, etc. Okay. Now, this m is the 4th of those integers. What would the fifth integer be in terms of m? M plus, it's even only. You gotta go up by how much? Not 1. Go up by 2. Again, if it was consecutive integers, it would be m plus 1. But since it's consecutive even integers, it's m plus an additional 2 on top. So we know that the fourth integer is m. The fifth one is m plus 2. What would the third one be? What would the third one be? M minus 2. Very good. 2 less than that. Well, what's the second one? What's 2 less than m minus 2? M minus 4. Very good, Ida. M minus 4. And the last one, or the first integer, would be?
M minus 6.
M minus 6. I ran out of room, sorry. And we want to know what is the sum of these 5 consecutive integers. So we're adding these all together. How many m's do we have, everybody? Everybody? 5. And then we just have to add up our numbers. The negative 2 and the positive 2. Just cancel them, please. Realize that they cancel each other out. It's a balance, right? And then we get negative 10. Questions on this one? Again, we're collecting terms on the last step. Yeah, because it doesn't say to find the number. It says in terms of m. Let's go over that. Whenever it says in terms of, if I said, give me the answer in terms of x and y, it means that x and y are going to be in your answer. So when you see in terms of m, you better get an m over here as an answer. Okay? Questions? Good? Alright. Alright, now we get to some fun stuff. Example 5, a train. This is where you want to draw a diagram. A train leaves town traveling at 50 kilometers an hour east. 3 hours later, another train leaves town traveling 75 kilometers an hour, also east. On the same road, or I guess the same track, I should say. How long will it take the second train to catch up to the first train? How long will it take the second train to catch up to the first train? Alright. So this kind of a problem is a little bit tricky at first. But if we remember our distance rate relationship, we can make this easier. So what was that formula again from before? D equals RT. That's going to be our governing equation here. But how many trains do I have? 2. So I need how many equations for this part? I need to do 2 times. Alright. What is the distance that they're going to travel each? Do we know what the number is yet? How far they're going to travel? Does it say it anywhere? But we do know something. We do know something. If, or can you let me know real quick? Alright. If we were stand side by side, Worth and I, and Worth starts walking ahead of time, so walk slowly, and eventually I leave about, it looks like 3 hours later, and I travel a little faster, eventually I'm going to catch up. And then we pause. And when we catch up, this is what we want to know, right? So, what do you know about our distances with regards to one another? We don't know how far apart from the origin we are, but we know something about our distances. They're equal. Very good, thank you. They're equal to one another. Okay, so no matter what in this problem, I don't care what the distances are, but I do know that they're equal. So let's keep that in the back of our mind. Okay? So in the top right, write down D1 equals D2. Because we know that the distances traveled are going to be the same in order for the train to catch up. Next, what is some other given information that I know? What is something else that's given?
Well, the first train has been traveling for 3 hours at a mile and 50 hours. So,
I asked for given. David, answer the question. David. What's a given?
well,
Give me a given.
the other train is traveling at 75.
Okay, so one train is traveling at 75. That's a given. Good. And I'm going one step at a time. I know you wanted to go on there, but just bear with me for a moment. So that's one given. Okay? We can call that R1, R2, it doesn't matter, one train or the other, right? Worth, what's another given?
The train that left first is traveling at 50.
Kilometers per hour. Good. 50 kilometers per hour. So those are both given. There's actually one other piece of information that's interesting. What else do we know, Ida? That's one way to think about it, sure. Because the first train left 3 hours ago, it's already got a 150 kilometer head start. But there's an easier way to do it. You could do it that way, but I think it's a little more complicated. There's an easier way. what can you say about the relationship between the times? Between the times. Focus, people, focus. What can you say about the relationship between the times of the two trains?
T1, like which is the first train,
Uh-huh.
is...
Well, we called it 2, just to be careful. Sorry.
So
We could switch them.
T2 plus 3 equals T1.
Very close.
T1 plus 3
Yeah.
equals T2.
So, one of the trains, no matter what, is going to travel for an extra 3 hours of time. Right? It started 3 hours earlier, so the time elapsed by one of the trains will be 3 hours more than the other. Which of those trains? Well, it's the train that was traveling at 50. We called that R2. So we could say that train that's traveling at 50, T2, is the same time as T1, but it's 3 hours more. And I know this is going to sound weird, but it'll make the problem a lot easier on you. Okay? So train 2 travels for the same time as train 1, but for 3 hours more. Okay? For 3 hours more. Now, for a problem like this, we're going to have a few different equations. So let's write down first. D1 equals R1, T1. D2 equals R2, T2. What do we know about D1 and D2 though? What do we know about D1 and D2? Summer. They're equal. So Chris, what can I do if they're equal? Since D1 and D2 are equal, what can I do with these equations? Yeah, put an equal sign between them. So let's do this. Again, the distance traveled by each train is unknown, but it's the same. That's the key here. You could set them equal to each other, okay? You could set them equal to each other. And at this point in time, we've got enough information to solve, actually. We do. What is the question asking us for again? Find the time it takes
Yeah, for the two.
to catch up. How long would it take the second train to catch up to the first? Okay? So, for this kind of a problem, by the way, we should have definitely switched the subscripts around. It's kind of confusing, right? Do you want to go back and change them real quick? Switch this to 1 and 2 and switch these two real quick. I'll do it on the board so you can see what I mean. Just because it's going to cause a lot of confusion, I think, in a moment. I'm going to do it in blue so it writes over. It doesn't matter, but it makes it easier to write it the other way. Okay? So just to be careful so we're not, because in a minute, it's going to say the first train and second train, yeah. So, what we can do is plug in what we know into this equation. So you know R1 and you know R2. Plug those numbers in, right there. So R1 is 50, and R2 is 75. Now, we still have to plug in for T1 and for T2, but we know something. We know something else. We have another thing written down that we haven't used yet. We use this, we use this, we use this, we use this. We've used all those, but we haven't used that last equation. So who has a suggestion as to what we should do here? We have not used that last equation yet. Tori May.
Say that T, put in the other one T plus 3.
Good. So in for T1, let's put what we have for the definition of T1. So take this T2 plus 3 and put it in there for T1. Remember substitution method you heard before? Where you can substitute variables? That's what we're doing. So call this T2 plus 3. If I could write neatly, it'd be nicer. Hold on. T2 plus 3. Why does this help me now? What does this allow me to look at and realize? What does it allow me to look at and realize? You can distribute, absolutely, but how did this help me? Why can I continue to do this problem? Why am I allowed to?
You only have one variable.
You only have one variable now. A moment ago, even when we plugged in the rates, we still were missing T1 and T2, weren't we? When you plugged in the rate 50 and you plugged in the rate 75, you were still missing 2 times. But because of this relationship, T1 equals T2 plus 3 more hours, and plugging it in there, it gets rid of T1 because it puts it in terms of T2, and now it's all one variable. So at this point, we can just solve for T2. Okay, just go through the process, and this should be the easy part. The hard part is what we did already. So we've got 50 T2 plus 150 equals 75 T2. Subtract 50 T2 over there, and that gives us 25 T2. Dividing by 25, we get 150 over 25? 6. And what are the units? Because it's in time? Hours. I heard it. Give me 1 second. So, for T2, we get 6 hours. We get 6 hours. And that's what the problem was asking us for. It said, how long is it going to take the second train to catch up to the first train? That's why I went back and switched the prefixes. Okay, because I realized at the end, this could be very misleading if it was the other way around. So the time it takes is 6 hours. So tonight what you should do is finish up 1/7 for sure. Finish up 1/7 for sure. And then I'll let you guys have the weekend to do 1/8. So if you want to finish up 1/7 tonight, go over from last night, do your problem set if it's not already done, have that for tomorrow. And then over the weekend I'll give you time to do 1/8. We have like 1 or 2 problems left in 1/8. We can do those tomorrow in the beginning before we review. Okay? So again, 1/7 homework and your problem set tonight. Okay, good luck with the track meet. What else about this problem can I write? So we just did the animation. We saw that they spread apart by distances d1 and d2. We want the sum of those. But what else do we know? What was Summer's velocity when she was walking? 8 miles an hour. So we'll call that R1. Okay. What was Worth's velocity when he was walking? Or say speed, I'm sorry, because velocity would indicate a sign. Francis?
6 miles per hour.
Good. 6 miles per hour. Okay, well done. What else do we know about this problem? There's another piece of information that we know.
When Worth leaves the house, Summer's already 8 miles away.
Okay, that's one way to think about it. When Worth leaves the house, Summer's already gone 8 miles. Summer's already 8 miles away. Very good. Summer's already 8 miles away. We can use that. Now, how would you like to use that? Because I solved it a different way, but this way does work. So I want to go with this story, man.
Okay.
It's different, but it works.
So you could, so it's Summer, you could set it equal
Okay?
because the same hours. Wait, I'm lost. I think it's like, I don't know.
Well, let's say after an hour occurs, Summer's already 8 miles away. So let's tack on an 8 right here, if we're going to do it this way. This way works. It's different than you'll see in the notes, but that's fine, because I want you to see different interpretations. So, we'll tack on the 8 from Summer's first mile that she walks. Now, it says, how far apart are you W hours after W hours have gone by? After W hours. If we already put this 8 here, then how many hours are we accounting for after that? Not W anymore, but what? W minus 1 it would be. If you already take into account the first hour that Summer walked 8 miles in, or ran, I guess, 8 miles in, then really we're not thinking about W hours anymore. We'd be looking at W minus 1 hours. So our time for each of these would simply be W minus 1 hours. Oops, I got it off the screen. It would be W minus 1 hours. Again, different way of solving this problem, but I like it. It's going to work for sure. So, we want to find out the distance that Summer travels, the distance that Worth travels, and we're going to do that for not W hours, but 1 less than W hours, because we already took into account the first hour. Here is the first hour, because only Summer was moving, so we don't have to worry about the rest. What is my formula that relates these variables that we're looking at? What's the general formula we talked about yesterday that I told you really need to remember for this class? You're going to use it over and over again, Austin. Good. D equals RT. Very good. D equals RT. Now, we have 2 different scenarios, D1 and D2, so let's write them both out. The distance that Summer travels, D1, is going to be her rate times the time she runs for. Again, after the first hour that we already took into account. The distance that Worth travels, D2, is his rate times the time he travels for. Again, 1 hour less than the total hours from when Summer had left. What are we going to do with those two quantities? What does it say in the beginning? What did we write? What was our equation? What statement did we make in the beginning? Yeah, we're adding them. Very good. We take D1, we take D2, we take 8, and we add them together. Well, look down here. This is D1. This is D2. So take D1 and plug it in here. Take D2's expression, plug it in here. And then from that point, you can sum them all together. So let's take a look at see what that looks like. God bless you. D1 plus D2 plus the 8 miles that Summer ran to start the race. Let's sum them together. We're going to distribute. We're going to distribute. What happens to the 8s? They cancel out. Okay, and that's going to be very interesting to see. We're going to talk about the meaning of this answer in a moment. It's kind of cool. When we cancel those out, what are we left with? How many W? Francis?
14.
Yeah, and what else? Go ahead. Minus 6. So this is the distance apart they are, or this is the gap between them after W hours have gone by since Summer left the house. Okay? Now, this is really kind of cool what I'm going to show you next. Because these numbers don't look like they have any meaning at all. At first you're like, all right, 14W minus 6, great. But you can actually talk about what everything means in this. Anybody have any idea what the 14W, where does that come from? 14W. Think about the problem. This is where we start to really think about problem solving. What does the 14W, or what is the 14W's significance?
Because the Summer at 8 and we're around 6.
Yeah, what are their rates? 8 and 6, right? If I'm here and somebody else is here and we're moving apart at 6 miles an hour each, it'd be like we're moving apart at 12 miles an hour. Because he's moving this way at 6 and he's moving this way at 6 at the same time. So this gap is really opening up by 12 miles an hour. So what's the sum of 8 and 6? 14. Okay? After W hours have gone by since she left. But did you run the first mile? The first hour? So what's your rate again? What was your rate when you were doing that? How many miles an hour?
6.
But you didn't run the first hour, right? So take away 6 for the first hour that you didn't run. So the 14W,
That was just
it's
kind of
like
cool.
mind blowing, right? So the 14W is the 8 and the 6 because you're separating, okay? And it's like when you're on a train. If two trains pass each other, it doesn't look like you're going crazy fast because you're really adding the velocities together in a sense. Because this one's going that way, this one's going that way. So relative to each other, it looks like you're going even faster. So the gap is increasing at really 14 miles an hour, but Worth didn't go for the first hour, so we take away the 6 miles that he could have covered in that first hour. Okay? So when you get your answers, make sure you understand what it actually means. Now, the interesting thing is, if we start using numbers, you don't see the powerful part of this equation. Because if I told you it was 6 hours, what would you plug in for W? 6. So you would just get a number as an answer. So you wouldn't always realize almost like the beauty of the answer, you know what I mean? Or what it actually means. Because you get a number, you're like, oh, okay, it's 100, it's 110, whatever it is, right? But now that you have variables still, you can see that it has a really large significance on the problem. Questions on that one? All right, so on your test on Monday, you have word problems sometimes that have answers with variables in them. I might say in terms of t, figure out such and such, or in terms of this. So when you get an answer, you don't have to just have a number, okay? So in terms of means that variable is going to be in the answer, okay? Like we talked about yesterday. Example 7. Try this one on your own. Try this one on your own. I want to see an idea of how people do. And I'm going to give you one hint, and that hint is this. Please use let statements. Let X equal this, or let Y equal this, or you could say G and B for girl and boy, but use a let statement in this problem.
So you're not going to get a number answer?
This one, well, you have to figure that out yourself. I'm not going to tell you yet. But just try and start with what you have in the problem, write a let statement, define X and define Y, and try and make an equation out of it.
So we would say let B equal. Okay.
Read the last sentence and you can see what you're looking for. Okay? Again, the let statement answers the question. The question says how many students of each gender, so you should have 2 let statements. Okay, students of each gender. Okay, we're looking for an amount. Later on, that's going to be a big difference there. So that's good so far. I like that first statement. I like that first statement right there. This was the first one. So this is a let statement. Now you can come up with an equation based on the process. Well, the way you did it, that's enough. You don't need more than one let statement. You could do it a certain way that you have two let statements. Some of you have two let statements, some have one. It's two ways to do it. So either is wrong. They're both right. I'm going to solve the problem. I'm going to show you the two ways I've been seeing let statements, because they're both right, and it's interesting to see this. This is what I was thinking, and you'll see this in the notes. I was thinking this: let B equal the number of boys, and let G equal the number of girls. That's what my thought was at first. And then I was going to write an equation. Some of you already started by doing this. Some of you said the number of boys is 4 less than twice the number of girls. And that was your let statement. That's fine. So if you started on the right side, it's okay. But what I meant by let statements, just so we're all clear, is you're defining your variable. So you should have some definition. If you started with this, that's good. But please also include this. Okay? If you started with these let statements, then your next step should be to come up with this statement on the right-hand side.
Do you have to have like B and G, or can you just use?
X and Y is fine. I use the first letter of the word I'm looking for, just so it's easy to remember.
Like X and Y, or could you just say let X equal the number of girls?
Sure, but we also want to know the number of boys, right? And we have a relationship. Read. The number of boys is, I'm going to do this on the board. The number of boys is 4 less than, twice the number of girls. Twice the number of girls. So we need to relate two variables here. So yes, there are two variables. Now, that's the statement that we've got so far. That's all we can say, except for our overall equation now. What was the first statement of this problem? So give me an equation I could write to govern this on the bottom without using this yet. What would you say? 26 total. So what plus what?
Without using the 2G.
Yeah, don't use the 2g minus 4 here. We'll substitute that in.
B plus G equals 26.
Very good. The number of boys plus the number of girls is 26. Good, Arthur. Now, what do we do at the next step? What do we do the next step?
Substitute the B for 2G minus 4.
Good. So put 2g minus 4 in for this b right here in the front. Substitution method, okay? At this point, you can solve. Should get g equals 10, it looks like. Add 4 to get 30. You have 3g. Divide by 3, you get g equals 10. Well, if I didn't make a let statement in the beginning, I may not know what g meant. I probably do. But I could look back up and say, oh, g was the number of girls. So that means there are 10 girls. If there's 10 girls, how many boys are there? 16. All right? Does that problem make sense? That's a perfect SAT problem. They give those a lot in the SAT, where they have a relationship between the number of people in a group. They talk about the sum of that group, and then you find the amount of each person in that group. And chances are, on an SAT, they say, how many boys are in the group? And one of the answer choices is definitely 16, because there are 16 boys. What would another one of the answer choices be to try and trick you out?
10.
10. Because in case you solve for x, and you got x equals 10, so many students just jump right away like, oh, I got x equals 10. But maybe x was represented by the number of girls. So you have to go back and think about what y was actually. So make sure you're answering the question that's being asked, especially on any sort of multiple choice question. Okay? So work on this weekend if you'd like. All right? For section 1.8. It's stuff from 1.8 and then some review from 1.7. The stuff from 1.8 a lot of the problems, you don't actually solve them, but you come up with an expression for an answer, like 2s plus 5 is like your answer. Okay, so you're going to see that a lot with these problems here. All right, let's stop there.